The presentation is about Scratch, an end-to-end application-aware soft GPGPU architecture and a trimming tool. What's a Scratch? Scratch is an end-to-end soft GPGPU parallel architecture supporting native OpenCL code that is fully implemented on FPGA, as well as a trimming tool that helps adapting the architecture. The work is based on an improved version of the original Miao system. According to the definition of the Scratch, firstly, I will simply introduce the soft GPGPU and FPGA. Soft GPGPU is a general-purpose parallel and programmable architecture on reconfigurable fabric. One approach is relying on existing commercial instruction set architectures, ISAS, which is an abstract model of a computer. Another one is developing special-purpose architectures like FlexGrip. FPGA is a portable, flexible, and scalable soft processor, and is a multi-core GPU-like architecture. Its ISA is designed to support execution of OpenCL kernels. Although valid, these approaches present severe limitations at the functional level, which limits the adoption by a vast set of real-world applications. Now I will talk about the main features of the Scratch. Scratch is an extension to the original Miao architecture, has been fully validated on FPGA and bug-fixed to support a set of 156 instructions, including the new floating-point ones, and enhanced with 2 clock domains to isolate the critic paths of the compute unit and the remaining components, and a prefetch buffer within the compute unit to reduce the occurrence of slow global memory transcations. A compile time trimming tool that is able to identify the requirements of each application and prune the Miao2 compute unit architecture to the application-specific needs, releasing chip area for adding more compute units, cores, and thus computational power to the parallel reconfigurable architecture. Then I will talk about the strengths of the Scratch. Firstly, it allows testing a variety of well-known benchmarks that were not possible in the original Miao design. Furthermore, it could tackle important performance bottlenecks associated with both the critic path of the original Miao architecture and its memory access latency. Next, it allows tailoring the soft GPGPU architecture towards the application-specific characteristics, therefore minimizing the used resources without compromising the correct program execution. What's more, it turns more amenable for system developers. As long as the desired performance metrics are met, the proposed soft GPGPU tool is more friendly and attractive for application developers, which usually don't have the skills for programming the FPGA using hardware description languages. Finally, by releasing an open-source soft GPGPU that is implementable on FPGAs, it's possible to develop and test the impact of additional application-specific architecture optimizations that can provide additional performance gains while validating its impact on area, frequency, and power. Then I will discuss about the constraint of the scratch. One problem is the use of robots, drones, or other mobile equipment that typically have to capture and process the image and other forms of data from sensors that more often operate far away from power supplies. Additionally, energy consumption has a large impact on their annual running costs. Since the soft GPGPU is trimmed at a per application level, the trimming could be applied at a per kernel level, with reconfiguration occurring between kernel cores. That's all. Thank you.